Hello everyone, this is Sachin again, and today we are going to learn about how to set up a Kafka cluster in KRaft mode and also use Prometheus and Grafana for monitoring. So this is the Medium web page. I will share the link also in this video. So where it describes most of the theory part. So you can go through what is a Kafka, what is a KRaft mode. I'm not gonna spend too much of time on these things. Let's directly come to the deployment architecture. So at times, like when you are learning Kafka, probably a small Docker command is good enough for you to bring up a single node Kafka, and you can try out your stuff. But when you want to go beyond, probably you want to set up a Kafka cluster, probably a you know 3 node brokers, um, and also you want to see the matrices, what's happening, probably when you are bringing one node down, how it is behaving, what's the CPU usage, memory, and other Kafka related stats. So this seems to be a very daunting task, and in this tutorial I'm gonna make it a super simple for you guys. So all you need to do is just probably in less than 5 minutes in your um, laptop or MacBook, you can bring it up. So let's first understand the architecture first. So what I'm gonna do here is in one AWS. So by the way, this is deployed into AWS cloud. So in US East 1 region, I'll be bringing up 3 machines. One will be a T2 medium, and 2 will be T2 small. Um, the and all 3 machines will act as a Kafka brokers. So this is my main machine, the middle one. I'm calling it node 1 and master node, and these two, node 2 and node 3, are like worker nodes. Um, so I mean, it has nothing to do with Kafka master. Kafka, it's like just a master node because I'm using it for deployment for Prometheus and Grafana, which I will be talking about later. Okay, so every machine will have a Kafka broker deployed, and it will form a cluster. Primarily, I will create a cluster ID in my node 1, and I'll be using this cluster ID in both of these 2 machines, so they form the cluster. Okay, for voting, the port 9097 is used for quorum voting, and 9092 port, I'm opening it for the whole world, so it's of course not super secure, but this is good enough for testing from your laptop outside of your outside, like from anywhere in the public. Um, okay. Um, and eventually, once this Kafka cluster is up and running, I'll be deploying the Prometheus and Grafana. So this is the architecture. Let's continue. Okay, so this is my typical setup, that this will be a Kafka cluster with 3 machines in an AWS region. 9092 port I'll be using for reaching out to Kafka. It's HA and it forms a cluster, but of course it is intentionally not very secure, so it gives a good time to play you around and access your Kafka cluster outside of the region, probably from your personal laptop. Okay, and eventually each Kafka brokers will be emitting the JMS metrics, which will be scraped by this Prometheus, which will act as a a backend for these information, and eventually a Grafana for the UI perspective, displaying it. Okay. All right. So for my use case, these are the 3 nodes. The master node has this public IP and a private IP. You can see over here, and this is how they look once they are deployed into AWS. Okay. The one master node with T2 medium, and the 2 worker nodes with T2 small. Okay. All right. Now here's the main important for the configuration. For this setup, this is my Kafka directory, home Kafka softwares Kafka, and Kafka comes with a server.properties under config/craft folder. What I'm going to do here is in each different machine, let me bring it up this image. So this is the leftmost is my master machine, and these two are my worker machines, as you have validate these private IP addresses. What I'm going to do here is in the config craft has a server.properties. I'm going to copy in each of individual machines the server.property to server_1.properties, _2.properties, and _3.properties respectively in these machines. Okay. All right. Now once you do that, go to the last of the configuration, add these configurations. This will basically primarily define your particular node, like the advertisement port and the node ID. Basically the node ID should be unique for all these three machines, otherwise there will be a clash and it will result into an error. So for my first machine, node ID is 1, second machine 2 and 3. Listeners is like listening for 9092 and 9097 port, 9097 for voting, and 9092 is like for access to your Kafka broker. Advertise listener, like so I'm intentionally putting it as a public IP because once it advertise that, so basically publicly from anywhere you can access that, and I'm putting a security group in such a way that it allows for the whole world to access into 9092 port. Again, it's not super secure, but this is for demo purpose only. For your production setup, you adjust your security groups accordingly. Okay. For quorum voters, these are the private IPs. You can see 2587 is the IP address of the first machine, and then 2424 is the IP address of the second machine, and 2529 is the IP address of the third machine. So this controller quorum voter string is a constant, same for all these three machines. Only advertisement advertise.listeners will change in these configuration in each machines. So once this configuration is up in these three machines, the first thing we're gonna do here is to generate a cluster ID basically, and this cluster ID will be generated in the first machine only. So I'm in the first machine. You can see 2587, the first machine IP address. This command, once you issue, it will generate a cluster ID. This cluster ID will be used to do the format Kafka storage.sh file format, and you give this cluster ID which you have generated over here, and -c the configuration file server_1.properties. So this will bring up okay, and after that you just issue the command Kafka server start.sh and just give the server_1.properties in your machine 1. So this will bring up the Kafka. The same process needs to be repeated for these two machines as well. The only difference is in other two machines you're not gonna generate this cluster ID. However, you will be just using the same cluster ID which has been generated in the first machine. Then it will form the cluster. Now once all these three commands are executed, this will bring up this Kafka cluster, and this will it will form a Kafka cluster. Now that's fine. That's like set up your Kafka. How about monitoring? So for that I'm using the Prometheus setup. All these links are already here. This medium link I'll provide in this document. These all are linked here. You can download this agent. So basically when the Kafka brokers are brought up, one extra configuration I'm giving here is Kafka ops, is for Kafka options, and here this JMX Prometheus Java agent is being used, which will expose this publish this metric like on 7071 port. It will be available on this port for that particular machine, and the Kafka_craft.yaml should be provided as an input. So this, the first link is like basically when you click it, it will download this jar. You can see the preview of that link on the bottom left corner, and another one is this one. I just open a new link. So this is GitHub repository. This is my personal GitHub repository. I'll be putting the link for here in the video description. So once these two files are provided and then Kafka brokers are brought up, your JMX metrics will be available at 7071 port. Okay, so this is like about just publishing this metrics. But how about like getting information out of that. So once, so in all these three machines, this Kafka options will be provided. So all these machines will be, you know, publishing their metrics on 7071 port. Now all we're gonna do here is from the machine where we have deployed the Prometheus, right, which will be available at 9090 port. Here in this, when we are bringing up Prometheus in this configuration, we need to provide all these three machines at 7071 port, which it will scrape or pull that information to display it in its UI. So let's see that one. So we go down. This is just a reference command I have put it for bringing up Prometheus. So once you install Prometheus, you're gonna give us the Prometheus YAML file. I'll come to that in a moment. And the storage path, just give whatever path you want to give for storage, and these two another input params for template and libraries. Anyway, the most important configuration is the prometheus.yaml file, and primarily it contains, like, you know, what is your job name. So I'm just giving a Kafka job, and it will scrape at every 5 seconds of interval, and it will contact all these three machines 7071 port, and it'll scrape that information and make it available. So once this Prometheus is up and it starts scraping from all these three machines, the metrics can be accessed on your master node IP, the node 1 IP at 9090 port /graph, and you can see that, you know, something like this, where you can see all these three machines and what is their status for Kafka deployment. And if you go to the main home page by clicking Prometheus, and if you want to read a specific metrics, you can just type in Kafka, and, you know, you can choose any metrics which you want the information. Like I'm here using the active broker count, so I've selected this one, press execute. It will tell, like, you know, what is the active broker count which each machine is reporting, which is 3, because we have deployed 3 node cluster. And if you access this to a specific machine, and by the way, I'm gonna show everything how you can do on your laptop almost in no time in a moment. But if I go to any of the machine and just stop that Kafka service, and you can see it is inactive, and when you refresh this page, you will see that particular machine 2529, this one where I have stopped Kafka, it shows that it is down. Perfect. So this is Prometheus, and it is good to you know, see these metrics as numbers, but sometimes you want to see more graphs, and, you know, you want to aggregate information and lot other stuffs, and for that Grafana is used for visualization. With the simple command which I have already pasted here, the Grafana can be brought up and it will be available at 3000 port. You just go there, and then it will ask for login and password. You can give admin, and it'll take you inside. Here you have to go to data source and give your Prometheus as a backend, and just skip TLS certificate validation just for demo. It should be okay, and save it. So once your data source is set, Prometheus data source is set, you can actually import this JSON. I have already included. I'm just gonna show it here. This is the JSON, and basically it's for the same Kafka job, right? See this information over here. So so once you import it, it has a predefined what do you say, dashboard, where you can see a lot many matrices and graphs. It will be visible over here. If you want to see any other metrics, super simple, you just go to any of the graphs, just edit it, put the matrix name, and it will start displaying that information. All right, so this is theory, and let's see how you can do at your end. I'm gonna pause this video for a second before I log into my AWS console. All right, so I have logged into my AWS console, and just showing my S3 bucket, just to let you know that this is Sachin Learning bucket 00, just a temporary bucket in my account. So actually all these things, like bringing up this cluster, setting up Prometheus, Grafana, all this setup I have already, uh, all these binaries and everything has already been um, compiled, and uh, Amazon machine image has been created out of that. So we have to do almost absolutely nothing. Let me open EC2 console, and you go to AMI, and you know okay, let me switch the region first. Let's go to North Virginia. Okay, all right, this is a Sachin Kafka image, and I have made it public, so which means this image with ID ending with C35 is available for public. So you don't have to install any Kafka or Prometheus or Grafana. Everything is already compiled and placed along with configuration. Everything is put over here itself. So we just need to use that image, that's all. And only two softwares needed to use that image is you must have let me bring it a little down. Yeah, you must have Terraform installed. So I'm just in my temporary directory and there's no content over here. If I say Terraform version, so I have a Terraform with version 192 installed, and I have a AWS CLI installed with access keys and secret already set up. You can Google it how to do this. So basically it's the same bucket which I have already shown you. So I have a Terraform and AWS CLI setup, and that's all you need to basically bring the same infra which I have shown you over here. Okay, all we're gonna do here is just go to this GitHub repository. I'm gonna put a link again in description. We just clone this code, copy, and git clone. Let's clone that. Okay, and just change the directory. All we gonna do here, oh by the way, before just bringing it up, I just want to show you that tf vars. Okay, the only thing which you need to modify for your so that it can talk to your AWS is only these two parameters. Okay, remember this AMI ending with C35, this is a public image which is in North Virginia US East 1 region, so you don't have to change this because this is a public image. So if you provide this information, it can be accessible at your end as well. So you can validate this image. Let me copy, and let's go to my EC2 management console, and this is the same image 25. Okay, all right. So, and basically to once this Terraform will bootstrap this infra, it will it will basically copy some scripts and configurations. So it has to SSH to that box, and to access that box, this there's a key pair file and the key pair name which needs to be provided. So basically if you go to your EC2 dashboard, there's something called key pair. Okay, I have one key pair. So once you create this key pair, it will give you a name, and it will download a file in your system, save it somewhere, and only you have to give is the path where you have saved that. So this is the path where I have stored my PEM file, and Sachin KP US East 1 is the key pair name, is Sachin KP US East 1 is the my key pair name, and that's it. So once you adjust these two information, you can pretty much bring up this infra. If you want a different machines, you can optionally change instance type and master instance type. So master instance type is basically the instance type for the middle machine, the node 1, and for the other two it will be t2.small. Alright, so I just recommend to modify these parameters, PEM file and PEM key name, according to your AWS. That's it. So now all I'm gonna do here is, if you list, just go to /scripts, and it has two files, bootstrap infra and teardown infra. So because I want to bring it up, I'm gonna use bootstrap infra. Hit enter. So it will take probably a minute or two. I'm gonna pause the video for that time, and once this is done, I will bring it up. So before I pause, I just want to show you my EC2 dashboard, which has 0 instances running, so nothing over here. Let's get back after a few minutes. Okay, so still it is in the middle, probably after 30-40 seconds, and right now it has created the master machine. I'm just listing down my running instances. So after creating master, it will basically move to both the workers, so that's why you can see 0 and 1 over here. Okay, so basically my Terraform bootstrap infrastructure is done, and we can see that it has added 9 resources. All right, and this is the final output, and we can see over here that I'm just listing down some of the consumer commands and the producer commands and list topic commands just for simplicity, but the main two URL is like the Prometheus URL here and the Grafana URL. And let's go to AWS console and refresh it here, and we'll see all these 3 machines are created, 1 master and 2 worker. So if we click on the master machine, and we can see the public IP is 54.174.78.41, and if you remember, this is the machine where the master machine where Prometheus and Grafana both are installed. So that's why the Prometheus URL will also have the same public IP on 9090 port, and Grafana will again has the same machine IP with the 3000 port. Okay, so let's go to Prometheus first. I'm gonna control click on this. Okay, this you can see I'm just bringing this down. So this is machine IP and the graph. Okay, so here go to status and target. Now we can see these 3 machines all are up. So let's just for testing, I'm gonna bring 1 machine down. So let me go to, let's say, worker 2. I click on this, I get the public IP, and let me split 3 machines. So this is my machine 1, machine 2, and machine 3, probably in case if I need to access to all the machines, but let's go to second one. This is worker 2, so third one. So I'm gonna SSH, the user is Kafka, and we have to put the public IP because I'm gonna access it from my laptop. Okay, the password is also Kafka, so I'm gonna key in Kafka again, enter. Okay, so right now I'm in my third machine, and it can be validated by this IP address. It ends with 22213. 22213. Okay, so sudo systemctl status Kafka. So we see what the status, it is active. So I'm gonna do here is stop it. Okay, and again if I put status, we can see that this is inactive, so this is like dead here. Okay, we go to the Prometheus dashboard and gonna refresh it, and we can see that this is down, right? So let's bring it up back again. So start, let's put status. Okay, so this is active. All right, now if you click on Prometheus, anyway, let's check the target first. Okay, this is back again. Okay, now go to Prometheus, and if you want to take any metrics, just say Kafka. It will list down all the suggestions, whatever you want to pick it up. The active broker count, which I have already discussed before, and execute. This is active broker count, but as a matter of fact, you can choose any metrics and it will display that information. That's pretty much about Prometheus. Let's move to Grafana. Okay, so I'm in this directory. Okay, and the Grafana, so I'm gonna click the Grafana URL. It's the same IP but the different port, 3000. This is a fresh Grafana. It doesn't, at this moment, it doesn't know what is Prometheus and where is that. So just put admin because it's the first time it'll ask to change the password. I'm gonna choose the same one, that's okay for demo. So admin submit. So this is like inside the Grafana dashboard. Now you will be needing to connect to Prometheus, so I'm gonna copy this URL, leaving the /graph part, just the http:// the IP and the port. You go to connection, data source, add a data source, and choose Prometheus. Okay, okay, and then the Prometheus server URL, I'm gonna skip this one and leave everything default, save. So this Prometheus is set up. Now go to the dashboard. All right, and here I need to go to new and import that file. So I'm gonna search in temp t3. Okay, that file is in the resources and the configuration and Kafka overview.json, right? So I'm gonna drag and drop this file over here, right? Import. Okay, this is like you at least dashboard is set up, and I don't know, there's probably a small problem, but all you gonna do here is just, you see, go to any of this portlet and just click these 3 vertical dots and edit it, and you will see below there is a query right over here. You just my observation, I just press enter and then get back, it's the same thing, and the run query, and then it start displaying the graph, and then say apply, so this graph comes. So similarly, in other case like active brokers, edit, and just I press enter and then back, just modify a query a little bit. You see, I'm not changing anything, just a small change, so I can run this query, and then it shows the correct count, and when we apply, this portlet comes. So basically this is what I have done. I'm not sure what could be the problem, but that's okay for now. And once I have done all these things, you can see that this will be eventually, you can build any fancy graph by Grafana. So that's pretty much, and you can see, like, this seems to be a complicated architecture and a daunting task to basically bring up Kafka cluster and make it, form a cluster and bring up monitoring, but everything is super simple, and everything is packed into this particular AMI, which is for public to use, and with this Terraform code, it will just bring up this infrastructure. All right, I hope, and by the way, all these complications for cluster ID creation and then setting up Grafana, issuing these commands which I have already shown over here, everything is abstracted, and everything is like coded in Terraform script, so you have to do nothing except just running a script / bootstrap infra. That's all. All right, now once everything is done, all you're gonna do here is to basically we have invoked bootstrap infra. All I'm gonna do is the tear down infra, and this will bring down whatever it has created. All right, that's it for today. I hope you have learned something new, and I'll get back with more and more technical content. Thanks for watching.